Alright, good morning, good afternoon guys. This is our final lesson that you should have from me through video. So next lesson we should be all back together. So this is the final lesson for this unit. It's about symmetry, and your clear learning target is I can describe rotations and reflections that carry a polygon onto itself. Now just know a polygon just means a shape, okay? So any shape. Carry onto itself when a figure undergoes a transformation and the points move but the object does not move. So what it means is like this point can go here, this point can go there, we can rotate it, but the shape itself never moves. So wherever it starts is where it finishes. So here we go. What transformation can be used to map the figure onto itself? And why can some figures be mapped on themselves? So basically what you want to look for is you want to look for reflection or rotation. Alright, so let's start with rotation. So if I start here and I spin 360 degrees, I get back to where I started. If I spin 180 degrees, I get here. So rotations, it can spin and it still stays in the same place. Now I was thinking about reflections. If I split it, so you think back to elementary and middle school, you would draw reflection lines. So here, this point would jump over here, and this point would jump over there, and it would stay the same. You can also draw the reflection this way. So what we have to do is, I don't think we can draw this way because then it doesn't match perfectly. So what we have to think about is for reflections, we have to find lines of symmetry. And for a rotation, we have to find out how many degrees. Those are the two things we have to determine. Now we could have both, or we could just have one. So let's get to reflectional symmetry first. Reflectional symmetry is also called line symmetry. So what line splits it in half? This happens when a line can cut a figure perfectly in half. So which transformations map the figure onto itself? So let's think about the lines. So how many lines can we do? So we can do a line here. There's one. And we can do a line here. So that's two. So we have two lines of symmetry. Smiley face. Well, we can't go this way because the eyes don't have eyes down here. So there's only one. There's only one, and that's going to be right down the middle. So there's just one. There's only one line of symmetry for the smiley face. All right. Now down here, how many lines of symmetry does a regular hexagon? Now this regular, this means all sides are equal length. And that's important. So that means all these are the equal length. Well, we can go right down the middle. So that's one. We could go down these two. That's two. We can go here. That's three. But there's more. Corner to corner. Corner to corner. And then, so how many lines? Now it looks like more than it really is. If you start here, 1, 2, 3, 4, 5, 6, because when I get back to this line, that is that line. So we got a total of 6. Now how many sides do we have? 1, 2, 3, 4, 5, 6. So we have 6 lines of symmetry. That's actually a shortcut. Hexagon, 6 sides. As long as they are regular, that's how many sides you're going to have. Like think about a square for a second. How many for a square? 1, 2, 3, 4. But what about a rectangle? All the sides aren't the same. So like corner to corner doesn't work. That would just be 1 and 2. So 2 for a rectangle, 4 for a square. So when you're regular, it's the number of sides that you have. All right. So I kind of gave it away here. How many lines of symmetry do these have? So here you've got a rectangle. So we know we can split down the middle. And we know we can split down the middle. But we cannot fold corner to corner. So we can't slice this way. So this one only has 2. This is a trapezoid. So this is actually an isosceles trapezoid. And it's just going to have 1. Top half doesn't match the bottom half, so it's only got 1 line of symmetry. All right, so that's reflectional symmetry. All right. Now this can take us to rotational symmetry. So when a figure can be rotated about its center and still look the same. So it has to look the same. So for what angles of rotation does the figure map onto itself? So we have an equilateral triangle. Equilateral, all sides the same. All right, so we got the center. Now a full spin is 360. Okay, so you've got 1, 2, 3 sides. So a full rotation is 360 degrees. So what we're going to do is we're going to say 360 divided by 3. And that is 120 degrees. So if you went from A to B, that's 120 degrees. If you went B to C, that's another 120. So that's a total of 240. And then you get up here, that's another 120. So plus another 120, that is 360. So these are your answers. So we can turn it 120, we can turn it 240, or we can turn it 360, and it still looks the same. Now parallelogram is different because not all sides are the same. So if I spun it this way, it doesn't look exactly the same. So in order for this one to look the same, B has got to get all the way to D, and that's halfway around. So that's 180. And then D, you would have to get up here to B. So that's another 180. So the answer is here. We can't do this. So this only works with regular shapes, equal-sided shapes. So this is just going to be 180 and 360. All right, you got a 4-pointed figure. So if you let this be A and B and C and D. So A can go to B, B can go to C, C can go to D, and D can go to A. So those are equal sizes. So we can say 360 divided by 4, and that's going to be 90. So this first one is 90, and that one's 90, and this one's 90, and this one's 90. So from there to there, that is 90. 2 of them will make 180. 3 of them will make 270, and all the way back around is 360. Now if you notice, all these answers, the last number is 360 because everybody can spin 360. All right, last thing, point symmetry. When a figure has rotational symmetry of 180. So basically what it means is like, let's take this one. If you take a point right in the center and you go in a direction, so if we go towards A, and if you go in the opposite direction and you travel the same distance, you get an equal point. So this one, if you go opposite directions, you get equal points. So this one is yes. But if you take this one, if I travel up to A, I get a point. But if I travel down here, there is no point. There is no point down here. So this does not have point symmetry. So anybody that has 180 has point symmetry. Point. Point. No point. Because again, if I start in the center and I go over to D and I went the opposite way, I get to B. So there's equal points. So let's try. So what types of symmetry does this one have? Well, let's try point first. So point, if I go up, there's no point opposite. So point is no. But I do have line symmetry. So I got 1, I got 2, I got 3, I got 4, I got 5. So I have 5 lines of symmetry. I'm going to abbreviate here. And then what about degrees? All these are equal. So I can say 360 divided by 5. 360 divided by 5. That is, quick math, 72. So then I would have rotations of 72, 144, 216, 288, and 365 answers. So 5 lines of symmetry and then rotational symmetry of those degrees. All right, this one. Now this is a little tricky. It looks like it would have line symmetry because if I split it in the middle, the top matches the bottom. But the reason it doesn't is because of these points. So if we folded it down, this point doesn't have a twin down here. So no line symmetry. But it does have rotational symmetry of 180. So rotational, that's going to be 180 and 360. And we also have point, because if you start here and you go there and then you go there, so that's point. So you have rotational and point, but no line. Excuse me. And this one was no point symmetry. All right, last one. So I think we can see that we're going to have line symmetry. So you got 1, you got 2, you got 3, you got 4, you got 5. How many? 1, 2, 3, 4, 5, 6. Oh, I'm missing one. So we got 6 lines of symmetry. That's all right. We got more than that. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Oh, my bad, guys. 7 lines of symmetry. 7 lines of symmetry. So that means we're going to have rotational as well, because all these are equal sides. So we can do 360 divided by 7. Oh, I have to get the calculator out for this one. 360 divided by 7 is 51. I'm rounding here. 51.4. 102.8. 155.2. 206.6. 258, 309.4, and then 360. I'm going to have to round for the last one. Now the question is, do we have point symmetry? So we start in the center. Let's move towards this point here, but if we move opposite direction, there's no point. So there's no point symmetry, and we see it in these numbers. There's no 180. All right, so your summary: figures can map, carry on themselves by using reflections or rotations. three types of symmetry: reflectional, rotational, and point. And point symmetry is when we have rotational symmetry equal to 180. All right, guys. I think practice should be pretty good. Good luck, and I'll see you soon.